So tell me if you can see the whiteboard.
Yes, ma'am.
Okay. Homomorphism. Between groups. Let us understand that G, like having this operation star,
Yes, ma'am.
and G dash another group having operation star dash. B, two groups. Then mapping F G to G dash is group homomorphism if like F A operation B gives FA of this star dash, means we are taking operation of first group in domain, you can say, and we'll have here in codomain the like operation of second group here. Then we
Okay.
can say this is group homomorphism from G to G. Got it? This mapping is said to be group homomorphism, and we can define it as like this, where A and B belongs to G, means in first group. Okay.
Okay.
Now we need to find kernel and image also. Kernel. Let us take together kernel and image. The kernel of the homomorphism.
Yes, ma'am.
I'll explain you. I'm just writing.
Okay, ma'am.
Homomorphism F is the set of elements of G that are mapped to the identity of G dash. Means we can define as kernel, we write KER in short, of F is equal to take A which belongs to G such that FA is equal to 1, means identity of second group.
Okay, ma'am.
Got it? Yes. And image of homomorphism F, image of homomorphism F is the set of of elements of G dash to which at least I'll explain you each and everything. Okay, just I'm writing first and then explain you.
Yes, ma'am.
At least one element of G is mapped by F like this. Image of F will be defined as F A such that A belongs to G. So now let us understand kernel and image. Kernel of homomorphism F is a set of elements of G
Okay, ma'am.
that are mapped to the identity of G dash. Means all those elements of G which are associated with identity of G dash. Got it? Means we are taking all those elements as domain in which output, or you can say codomain related or range related to G dash.
Yes, ma'am.
Like for example, uh, have element A, B, C, and they are associated with the identity of this is G and this is G dash. So these all associated with identity of G dash. So this set is said to be kernel of F. Got it?
Yes, ma'am.
Yeah. So we as kernel F to G, we'll take all elements in G. This A is associated with identity of G dash. Just this is one is the identity and of G dash. This denote. Okay.
Yes, ma'am.
In the G dash in suffix which shows that this is identity of G dash. Okay.
Yes, ma'am.
Now let us understand image of homomorphism F is a set of elements of G dash to which at least one element of G is mapped by F. Means now we are taking elements of G dash, which at least one element of G is mapped by F. Like at least one, we are taking A, B, C. Here we are
Okay.
taking X, Y, Z. So all those elements of G dash we are taking here in image, which are associated with at least one or at most as many as we can have. So these elements will take in image F. Got
Okay.
it?
So,
Yeah.
ma'am, basically G dash is the set F, right?
This mapping, this C, we are taking this mapping F G to G dash. So G dash is codomain. We are taking
Okay.
as codomain, and its element in function also. Its element are set to be image.
Okay,
Okay.
ma'am.
Yes. And we can define image of F like this. Okay, because fa this is the result in as we say in generally y is equal to fx. Okay, so we are taking value which belongs to g, so result is image. Okay, and here this x is private. Similarly we are taking image here, this is image.
Okay, ma'am.
Okay, yeah, a is like kernel belongs to this which associated with only one. Okay, kernel in image we can take any elements which are mapped with elements of like codomain, or you can say GDES. But in kernel, we are taking only those elements which are mapped with identity element, not with any. Okay, got.
Okay, ma'am.
So this is the group homomorphism and its kernel and image. Shall we do next now,
Yes.
or do you want to ask
Yes.
anything? Okay,
No,
okay,
ma'am.
okay, okay. All right. So we can show this group homomorphism by using pictorial representation as like we are taking here G, and in this we have kernel F. Mm, this is G, and we are taking here kernel F, means in G, because not all those elements associated with identity element. So only few of them are associated with identity element of G dash. So this is identity of G dash. So all those elements which are associated with identity element are in kernel F. Okay,
Okay, ma'am.
and all those elements which are associated with this elements of G are said to be image F. I'm
Okay.
using different colors so that you can, like, these elements are in like in image of F, which are mapped with elements of this G, and these elements are completely different, which are mapped with identity element, and this is uh, G and G dash, and this mapping F is said to be group homomorphism. Now got it? Got it?
Yes, ma'am.
Yeah. So now let's do its types of homomorphism, like epimorphism, monomorphism. These we'll do, and endomorphism, and also automorphism. Give me a few seconds. We are going to start. Give me a few seconds.
Yes, ma'am.
Types of homomorphism. First, epimorphism. An epimorphism is surjective homomorphism. or we can say a homomorphism which is onto as a mapping.
Okay.
And in this case, the image of the homomorphism is the whole G dash, or we can define as image of F is equal to G dash.
Okay.
Means we are taking in this case all elements of G dash, because in subjective, like each element of like domain must be associated with any like element of domain. That is why we are taking all of these elements.
Okay.
Okay, got it? Because this is the condition to be surjective, or you can say onto, that each element of codomain must be mapped with any element of domain. So each element of G dash must be associated. That is why we are taking all elements of G dash. Now got it?
Yes, ma'am.
Okay. Now next type, which is, this is definition of epimorphism. Now next we are taking monomorphism, second type, monomorphism. An injective or one homomorphism is said to be monomorphism.
Okay, ma'am.
So in this case, kernel of F is equal to identity of G. And next, let's do isomorphism.
Okay, ma'am.
A group homomorphism is said to be isomorphism if it is bijective.
Okay, ma'am.
Means it is injective also surjective. So if it has both property, then it is said to be isomorphism. Got it?
Yes, ma'am.
Next type, endomorphism. Is third type, and fourth, endomorphism. Homomorphism, homomorphic mapping
Yes, ma'am.
F from G to itself G is said to be endomorphism.
Okay, ma'am.
Actually, they are in not directly in our syllabus, like endomorphism, epimorphism, but we
Okay,
have
ma'am.
homomorphism and isomorphism in our syllabus. But in some cases, means is type of the homomorphism. That is why we are doing them in brief. Okay, but
Yes, ma'am.
isomorphism and homomorphism we'll do in detail.
Yes, ma'am. Okay.
So this is endomorphism mapping to G to G means itself. Okay.
Okay, ma'am.
Next is automorphism. In a mapping F G to G is said to be automorphism
Okay, ma'am.
if it is bijective.
Okay.
Means here we can have any, okay, we can have any here in endomorphism, but in automorphism, mapping G to G, but it must be bijective, one and contour. Only
Okay,
then
ma'am.
we can say this mapping is said to be automorphism.
Okay, ma'am.
Okay, so let us understand by using pictorial representation of each epimorphism and monomorphism and also uh, isomorphism and auto. Okay, so let us
Okay.
understand one by one by pictorial representation. So first, epimorphism. In epimorphism, we are taking all elements of like GDES because this is only onto. That is why we are taking all elements.
Okay, ma'am.
Epimorphism. Uh, we have this G. In this, we have kernel F and this image. One, we have identity element, and with identity element, this kernel F all associate because all those elements are in kernel F, which are associated with identity element.
Okay, ma'am.
Yeah. So this is G, and this is G dash, and this is mapping F for epimorphism.
Okay, ma'am.
Next, for monomorphism, let us define as this is identity element of G dash,
Okay, ma'am.
image F, and this is identity of G and kernel F. This is entire. And all of elements of G dash are associated as in monomorphism. We have done already, but we are showing here by using this pictorial representation. So are you
Okay, ma'am.
getting this?
Yes, ma'am.
This mapping
Yes, ma'am.
G to G dash. Next, let us do isomer. This kernel F, identity of G dash, and this is identity of G, and this is image of F. Image of F must be equal to G dash, means
Okay, ma'am.
entire elements of G dash. And we are taking this as mapping in isomorphism.
Okay, ma'am.
Yes. And in automorphism, let's see. Hmm. Means in automorphism, this is in itself.
Okay, ma'am.
So this is identity element, and we are taking kernel, identity of G, kernel of F, and this is image of F.
Okay, ma'am.
This is automorphism. Hmm. Give me a few seconds. I'm just checking what is the next topic.
Yes.
Give me a few seconds. Hello.
Yes, ma'am.
Hello. Yeah, we have finished entire this unit. Okay, I want to see the past paper. Means when I want to see the what kind of question they are giving in exam, so that we can do accordingly.
Okay, ma'am.
This
Ma'am, I will arrange for papers because I haven't been to college for really long. So I will arrange for papers and I will show it to you.
Sure, sure. Because so that we can do questions accordingly. Okay.
Yes, ma'am.
Because
I will.
different, different university has a different pattern of exam. Some of them they give like numeric based questions. Some of them giving like theorems or facts to prove. That is why I want to check it.
Yes, ma'am. I
Okay.
will do that. Yes, ma'am.
Yeah. And on this weekend, I'll send you all 3 units of algebra by in notes. Okay.
Okay.
And want to do today next, or shall we start physics tomorrow?
Ma'am, we can start
First,
physics
I
tomorrow.
tomorrow. Okay, all right.
Yes, ma'am.
Okay.